What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find the value of a and b such that a squared minus b is equal to 73 and b squared minus a is equal to 73. There is a condition attached to this question which says a is not equal to b. Well, we can call this equation 1 and call this equation 2. Now notice that from equation 1, we have a squared minus b to be equal to 73. And from equation 2, we have b squared minus a to be equal to the same 73. That means this expression must be equal to this expression. And that's going to be our first step. So a squared from equation 1, a squared minus b must be equal to b squared minus a from equation 2. Our next step will be for us to move what we have on the right hand side to the left hand side. We've got a squared here already. When I move b squared to the left, it becomes minus b squared. When I move negative a to the left, it becomes plus a. And I've got negative b here equal to, since nothing remains on the right, this will be equated to 0. Now notice that this is difference of two squares. So let's express this in difference of two squares. So we have a minus b times a plus b. So this has been expressed in difference of two squares plus a minus b, and this is equal to 0. Our next step will be for us to factorize since a minus b is common. So let's factor out a minus b. So factoring out a minus b, we now have a minus b times a plus b divided by a minus b. I have a plus b, so a plus b plus, now a minus b divided by a minus b, I have 1. And this is equal to 0. Now using the 0 product rule, we have a minus b to be equal to 0, and we have a plus b plus 1 to be equal to 0. Now from this first case, we have a to be equal to, as negative b crosses to the right, it becomes b. And from the given condition, a is not equal to b. So that means we're going to be rejecting this. So this is rejected. Now let's focus our attention on our second case. For our second case, we're going to be applying substitution. That means we're going to be making a to stand alone by moving b and 1 to the right hand side. So a will be equal to, as 1 crosses to the right, it becomes negative 1. And as b crosses to the right, it becomes negative b. So a is equal to negative 1 minus b. But you notice that negative is common. So we can factor out negative so that we have a to be equal to, so factor out negative or factor out negative 1. So negative 1 divided by negative 1, I have 1. And negative b divided by negative 1, I have plus b. So a is equal to negative 1 plus b. Now we're going to be substituting this into equation 2. I would have done that for equation 1, but in equation 1, a is carrying a power. I don't want to make things complicated. So I'm going to be choosing equation 2. So In equation 2, we have b squared minus a. What is a? A here is negative 1 plus b. And this is equal to 73. Remember, this is a. So b squared minus times minus gives plus 1 plus b. And this is equal to 73. Our next step will be to rearrange by moving 73 to the left-hand side. So we have b squared plus 1 plus b, and as 73 crosses to the left, it becomes negative 73. And this is equal to 0. Now let's add this and this. So we have b squared plus b. Now plus 1 minus 73. I'm going to be having negative 72. And this is equal to 0. Now notice that we have a quadratic equation to work with. Let's continue on the next slide. Now for this quadratic equation, we're going to be using the general formula to solve this. Now from what we have here, we see that the coefficient of b squared is 1, and that's going to be our a. The coefficient of b is 1, and that's going to be our b. And the constant term is negative 72, and that is going to be our c, negative 72. So the quadratic formula we're using is b equal to, remember this is the b we are looking for, the main value of b we're looking for. This is different from this. This is just a coefficient. So let's go, negative b plus or minus the square root of b squared minus 4ac all over 2a. So the value of b now becomes negative b. B from our equation is 1 plus or minus the square root of b squared, that's 1 squared, minus 4a. A is 1, c is negative 72 all over 2a, that's 2 times 1. So the value of b now becomes negative 1 plus or minus the square root of 1 squared is 1. Now negative 4 times 1 times negative 72, I have plus 288 all over. Now 2 times 1 is 2. So b now becomes negative 1 plus or minus the square root of 1 plus 288 is 289 all over 2. So b will be equal to negative 1 plus or minus. Now the square root of 288 is actually 17 all over 2. So let's separate. So we have b to be equal to negative 1. Go with the plus 17, divide by 2, or b is equal to negative 1. This time, let's take the negative 17, divide by 2. So from here, you see that b is equal to negative 1 plus 17 is 16. Divide by 2, which gives a value of 8. Now from what we have here, b is equal to negative 1, negative 17 is negative 18. Divide by 2, so this gives a value of negative 9. And from our given equation, let me show you real quick. Now notice that the equations are symmetric, which means if I swap the positions of a and b, the expressions will still be the same. And for that, we can say the value of A and B are, for example, when A is 8, we take the value of B to be -9. And when A is -9 this time around, we take the value of B to be 8. And this is our final answer. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.